Hello friends, welcome to Susan and John MathTube. This is lesson number 20 in the examination preparation series for the first year engineering students. And from this lesson, we start a completely new topic, that is differentiation under the integral sign. And this topic is really important for your exam. Now, the aim in this lesson is to give you a foundation for differentiation under the integral sign. Look at this. If you want to apply Leibniz's rule in integration, you should be very good with a concept called partial differentiation. And that is exactly the aim of this video. And as always, the 5 important points. Point number 1. Are you ready with a pen and a paper? And point number 2, I hope you're going to work out all the problems along with us. And the third one, the fourth one, and the fifth one. And let's start the topic, differentiation under integral sign. So look at this. This topic or this lesson gives you a clear foundation for differentiation under the integral sign. I'm sure you have seen this symbol d by dx. It's simply ordinary d. Some people use the notation capital D. It means the same. It's the same operator. Now I'm going to introduce you to a new thing that is called curly d or dou, DOH. Some people call like dou, and some people use partial derivative. So you can call curly d, and whenever you see curly d, you're going to show some sort of partiality. Okay, so let's take a look at a function, a multivariable function, x square plus y cube. And suppose you want to find the partial derivative with respect to x. You have to understand the fact x will be treated as the only variable. Even though we have two variables, look at this. This is a function which is made up of two variables x and y. There are two input variables x and y. But when you perform the curly d, the partial derivative, dou u by dou x, what you do is you treat x to be the only variable. And that means my answer will be 2x plus constant, that is 0, because x is the only variable and all the other letters you see will be treated as constant other than the independent variable. Now suppose you want to find the curly d of u with respect to y. That means I have to treat y as the only variable. And the answer will be 0 plus 3y square. So that's it, my friends. So let's suppose that you have a function in x, y, z. If you want curly d, the partial derivative with respect to x, you treat x as the only variable, or in other words, y and z will be treated as constants. At the same time, when you find curly d with respect to y, the partial derivative with respect to y, you treat y as a variable and the other two as constants. And similarly, the partial derivative with respect to z will be obtained by treating z as the only variable. X and y will be treated as constants. Okay, so suppose we have u equal to x cube plus y square plus z. Then the partial derivative with respect to x, that will be equal to, now look at this. I'm using curly d. One more time I'll tell you. If you see ordinary d, you do ordinary differentiation. If you see the curly d, you do partial differentiation. And when you do partial differentiation, you should focus on the variable given here, because that will be the only variable when you perform that differentiation technique. So my answer will be 3x square plus 0 plus 0. At the same time, if I try to find the partial derivative with respect to y, my answer will be 0 plus 2y plus 0, because y is the only variable. So these two will be treated as constants. And finally, suppose I find the curly d, the partial derivative with respect to z. And the answer goes like 0 plus 0 plus 1. Okay, now let's try another type. But before we start this type, I want you to take a good look at the function x cube y to the power 4 times z square. So look at this. In the first case, we have some plus here, and here we have a product. So I want to give you some basic things. If you see a constant, if you have a constant, the derivative will be 0. At the same time, if you have a constant into function, what you do is you keep the constant as such and differentiate the function to find its derivative. For example, 5 into tan 45 degree. Look at this. Tan 45 is a constant, 5 is a constant, so the derivative will be 0, because the derivative of a constant vanishes. Mathematically, vanishing means the value becomes 0. At the same time, if I have 5 into log x, we have a constant and a function. So the technique tells me keep the constant as such and differentiate log x. Okay, with that knowledge, let's start curly d. So I'm going to find the partial derivative of u with respect to x. Now look at this. Whenever you see the curly d, you should focus on the variable given below. I have used yellow color here so that you can see that very clearly, and I'll use yellow here so that it gets highlighted. Okay, so who is the only variable? X. And remember, this is a product, it's not a sum. So I hope you are able to see constant multiplied by a function. Or in other words, the answer will be 3x square times y to the power 4 z square, because I kept the constant as such and differentiate the variable part. Now suppose you want to find the curly d with respect to y. If you want to find the partial derivative of u with respect to y, this time y will be the variable. Who will be the variable? Y. So I keep the constants x cube and z square as such and differentiate that y part. And finally, and now you are an expert with this, so what might be the partial with respect to z? What is the curly d with respect to z? I keep the constant and differentiate the function. Okay. Now before we move on to the next type, I want you to focus on the formula d by dx of x to the power n and d by dx of a to the power x. Look at this. The derivative formula is n x power n minus 1, and I'm sure most of you know the formula. And here the derivative formula is a power x ln a, or you can write a power x log a to the base e, or even casually you can write a power x log a. But nowadays many mathematicians reject this, but we see the same thing in your books, so it's okay. But the proper notation is ln a, that stands for the natural logarithm. but some of the mathematicians believe in calculus you can use logarithm for ln(a) because it is assumed that calculus has been developed with the assumption it's to the base e. Anyway, it's your choice. Okay, now the focus is, look at this. The first one, x is the variable and n is a constant. And the second one, a is a constant and x is a variable. I'll give you an example, 7 to the power x. Okay, this one, constant to the power variable. 10 to the power x, exactly this one, constant to the power variable. X to the power 4, okay, variable to the power constant. Okay, so with that knowledge, let's try one problem. So you can write u equal to x to the power y. So what will be the partial with respect to, partial derivative, the curly d with respect to x? And what will be the partial derivative with respect to y? So let's try. So look at this. I want to find the curly d with respect to x. And curly d with respect to x means x is the only variable, or in other words, we have variable to the power constant, and that looks like the first one. And the answer will be y x to the power y minus 1. Now look at this, we want the partial derivative of u with respect to y, and which means y is the only variable. Who is the only variable? Y. And that means x is a constant, and it looks exactly like our a power x, constant to the power variable. And the derivative will be, you copy the same thing and log of the constant. Did you see that? You copy the same thing and log of the constant. Okay, now let's try one question which is very, very important in the next lesson itself. That is in lesson number 21, when we start differentiation under integral sign. Once more, let me convince you one thing. If you want to learn differentiation under the integral sign properly, you should be very good with the basics of partial differentiation. Or in other words, if you are able to complete this lesson properly, if you understand this lesson properly, you will be literally enjoying lesson number 21, in which we learn differentiation under the integral sign. So you can try one question, u equal to x to the power alpha minus 1 by log x. You will understand why I gave you this question in the next video. Okay, anyway, before we start, I'll give you one small information. Suppose we have a variable divided by constant. This is actually 1 by constant into the variable, and hence the ordinary derivative will be 1 by c times du by dx. And that is actually du by dx, the whole divided by constant. So we learned like this. Suppose you have a variable function by a constant, we just keep the constant as such in the denominator and differentiate the numerator. I hope you understood that point. Suppose we have to differentiate tan x the whole divided by 5. I keep 5 as such because the denominator is a constant. And the numerator has derivative sec square x, so the derivative will be sec square x by 5. Suppose I want to find the derivative of log x by sine 35 degree. Look at this, the denominator is sine 35 degree and that is a constant. So what I do is I keep the constant as such and the numerator becomes 1 by x. Okay, with this knowledge, I am going to find the partial derivative of u with respect to alpha. So look at this, I am going to find the curly d And when I find curly D, I'll be interested in this part. And that part told me alpha is the only variable. And I'll make it very clear for you. Alpha is the only variable. So, of course, the denominator is a constant. Look at this. Alpha is the only variable. So, x is a constant. And if x is a constant, log x is a constant. So, I'm going to keep the denominator as such because the denominator is a constant. Okay, now I can see constant to the power variable. Isn't it? Constant to the power variable. Okay, what's the derivative of constant to the power variable? Constant to the power variable and logarithm of the constant minus 1 is a constant, so that's it. So you simplify this, you get x to the power alpha. Let's try one more problem. U equal to x to the power a minus x to the power b, the whole divided by log x. Okay, I am trying to find the partial with respect to, partial derivative with respect to a. So when I find curly D, when I find the partial derivative, I'll be interested in this. Okay, and that tells me a is the only variable. Who is the only variable? A. And this is the only term which contains a. So this is the constant, this is the constant. Oh, the denominator is a constant. So the rule tells me I keep the denominator as such. Okay, now tell me the derivative of numerator. Okay, I see constant to the power variable. So write the function as such and write logarithm of the constant. Minus 0. Okay, so I get x to the power a. Now you can try the partial derivative of u with respect to b by yourself. I'm sure that you can do it. Okay. Now let's move ahead to the next type. And before we start the next type, I want you to understand one thing. Look, I'm using d. D means ordinary derivative. Okay, can you tell me what is the ordinary derivative of e to the power 5 into x? I'm sure you know this. Yeah, e to the power 5x multiplied by the constant. Suppose you want to differentiate d by dx of e to the power minus 10x. Then what will be the answer? E to the power minus 10x multiplied by the constant minus 10. Or in general, d by dx of e to the power constant into x will be e to the power constant into x multiplied by the constant. Okay, with this fact, I want you to differentiate u equal to e to the power ax minus 1 the whole divided by x with respect to a. That means I want to find curly d of u with respect to capital A. So shall we give it a try? Yeah. So look at this. Whenever I want to find the partial derivative, the curly d, I will look at this part first. And this tells me a is the only variable. That means x is merely a constant. So the denominator is a constant. So I'm going to write the denominator as such. Okay, now tell me what is the derivative of e power ax? Yeah, e to the power ax multiplied by the constant. Look at this example, multiplied by the constant, generally also multiplied by the constant. Now look at this, a is a variable, x is the constant, minus the derivative of 1 is 0. So you end up with e to the power ax. Let's try one more question with this logic. So u equal to e power ax minus e to the power bx the whole divided by x. So my friends, what will be the partial derivative of u with respect to a? Okay, we are doing curly d, the partial derivative. Okay, so a is the only variable. That means x is a constant, b is a constant, and everything other than a is a constant. Okay, so the denominator is a constant. I keep the denominator as such. And this is a variable. I don't see any variables here, so this is a constant. So this will be minus 0. So here we go, we write the derivative e power ax into constant. So I get cut e power ax. So why don't you try the partial derivative of u with respect to b by yourself. Okay. Now one more thing and we can wind up this video and you're ready for the next lesson. And I have to give you some basics. I hope you're all good with chain rule, and before that you have to understand the derivative of 1 by x is minus 1 by x square. Okay, so suppose you want to differentiate 1 by log x. It looks like 1 by something. So I'm going to write 1 by log x the whole square. That's not enough. You have to differentiate this log x. So we get into 1 by x. Suppose I want to differentiate 1 by tan inverse x. So it looks like 1 by something, so the derivative is 1 by tan inverse x the whole square. But chain rule tells me you have to take the derivative of tan inverse x, which is 1 by 1 plus x square. Now I'll come to the point. Suppose you have u is equal to 1 by a square cos square x plus b square sin square x. I'll repeat once more. We are trying to create a very good foundation for the coming lessons. And remember, if you're good in partial differentiation, that means you're going to enjoy the next few lessons, differentiation under the integral sign. Okay, suppose I want to find the partial derivative with respect to a, the curly d with respect to a. Okay, I can see 1 by something, so I should write minus 1 by the same thing times. Oh, I have to differentiate this part. But the good news is a is the only variable. That means this is a constant. The whole thing is a constant. So I'll get something plus 0 for sure, but the whole thing is a constant. And here the answer will be 2a cos square x. I hope you understood that. Anyway, you can try the partial derivative with respect to b by yourself. You're going to get something similar to this. Anyway, my friends, we're going to wind up this video right now. If you like the video, please share and subscribe. I'll be back with differentiation under integral sign. So till then, my friends, bye.